Okay, we finished our morning algorithm, so welcome back, everyone. We're going to do our lecture on APIs. APIs. And if you're in this lecture now, you have completed your exam. So congratulations. And if you're listening to this lecture on a recording, you have probably finished your exam as well. So congratulations to you. And all right, so let's dig in. What are APIs? Well, actually, before I open up the lecture, let me just mention these 2 days, we're going to be going over bonus material. This is really supplemental to your knowledge. It used to be required at some point, not APIs, but some of this, like media queries used to be a must when doing web development, but now we've shifted it to after the exam. So let's go over this material, and this afternoon we'll go over terminal and get. So I won't explain what these topics are until we get into them, so we won't waste time. So let's go over APIs right now. All right, so I prepared a slide for this. So let's go over our slide as a way of introduction, but if you would like to follow along some of the code that I may be presenting, you'll see here in the platform, if you go to JavaScript and then below terminal basics, below the yellow belt, there's advanced topics. I'm on the APIs and AJAX. Okay, so you can see a lot of the information I'm going to present here. Okay, I have it in different wording, but it's all this information here. Okay, so I'm going to introduce us to this topic, APIs. Okay, so here's our slide. Let's go over a brief overview of what APIs are and how they work. Okay, I made this cool looking, well, it's kind of blurry, but I thought it fit APIs because we're dealing with stuff that we can get on the web. So what is an API? API stands for Application Programming Interface. Okay, but what does that mean? We'll get into that. Which is a set of defined rules that enable different applications to communicate with each other. Okay, so an API, which stands for Application Programming Interface, is a set of rules that one application can get from another. So imagine you build an app, someone else builds an app, and you can incorporate their app into yours through an API. Okay, so let me give by way of example. Think to yourself, let's imagine that you are the owner of the Target. Somehow you've inherited your next local Target through family inheritance. All right, you didn't know that your family was rich, but now you just got a Target. So you're in charge of management and, managing the whole thing, logistics, right? The shopper experience, they're coming in, they're going to your store, all right? And you notice that you can get shoppers to stay longer if you offer them a beverage like coffee while they're shopping, okay? So you as the Target owner, the owner of the store, you can think to yourself, well, I can start selling my customers coffee from the coffee that we sell on aisle 7 or something. We can take those grounds and build a coffee bar from scratch, or we can borrow one from Starbucks. Starbucks is a business already, and they're able to work within other businesses. They have a system that they can easily adapt. I don't have to recreate the caramel macchiato. Someone else already took care of that system, that structure. I'm just going to allow them, allow the Starbucks into the Targets, right? So we see that a lot of time, businesses within businesses, so that they can manage themselves, right? Target doesn't have to do all of management, including how to train baristas, how to get the coffee beans, and and set up the look of the standardized coffee view. So that would be an example of using like an API, a system that's already built and you're integrating it into your own. So that's what an API is doing. You're taking a system that's already created, you're taking that data, or you're taking that structure and adding it to yourself, adding it to your own software. So APIs are a software intermediary that allows two applications to talk to each other, and they're an accessible way to extract and share data within and across organizations. So APIs can be free databases that you find online. APIs can be software that's hidden within a company that only company members can use. So APIs come in all shapes and forms. Okay, they hide internal details of how a system works, exposing only those parts of a programmer will find useful and keeping them consistent, even if the internal details later change. So it's a system already built. The programmer can borrow from this API and incorporate some code into their own without having to build it from scratch. Okay, so let's see how it's used to get a better understanding. How is an API used? Okay, APIs are all around us and we use them every day without realizing it. So when we use a rideshare app, send a mobile payment, change the thermostat temperature from our phone, we're using an API. We're using a program that we're incorporating it into our phone. So we can think of an app even as an API, okay? They're used to enable communication between different software components. So you can use multiple APIs within an app, okay? They're the building blocks for creating applications and integrating various services. I don't think we need to see that very well. APIs are used for various purposes, including data sharing, app integrations, embedded content, systems. Hello, Austin?
Oh, sorry, I didn't mean to unmute.
Okay, great. So they're used in various ways depending on what the need is. When I worked at a bank, well, they had an API system that's a lot like the topic we'll be introducing tomorrow, which is Bootstrap. Bootstrap's a CDN, it's not an API, but Wells Fargo had an API system that in order to build, for example, a login form, I couldn't just use HTML from scratch. I had to borrow from their API, which used HTML. So let's give a less complex answer. I was once building a e-commerce app, and I didn't want to create the system that would store order information and track, if the order was charged or if it was returned. So there was an API already built for that called Stripe that can charge credit cards. It could manage orders, and you can see an order history. So I wanted to just borrow that instead of writing it from scratch. There's an API already built for me when I was working on that app. So there's lots of APIs that can help you with your app. Okay, APIs, they a lot of the time, well, for now in this collection of technologies, HTML, CSS, and JavaScript, we'll be using JSON. JSON stands for JavaScript Object Notation. And do we remember yesterday when we went over objects, what an object was, how it was stored within curly brackets, how it had a key value pair? This language, JSON, it stands for JavaScript Object Notation. So it's a way to read objects in JavaScript. Let's look at a bit more into JSON because we're going to be using JSON with our API. So JSON stands for JavaScript Object Notation. It's a lightweight text-based format for storing and transporting data that uses human readable text to store and transmit data objects. Okay, so it's data stored in objects like what we went over in algos yesterday, objects that store key value pairs. JSON is often used when data is sent from a server to a web page. When data is sent from a server to a web page. JSON is commonly used for transmitting web data. All right, so let's take a look at what JSON looks like just to get a quick view so it doesn't escape our memory. So let's see. Do I have it here? This is here a view of an object, right? Do we all see that this object starts with the curly bracket up there? Maybe if I increase the font. Up here, up top left, there's an object. So this is an object that I would get data from in an API. And I'm going to use this extension to clean it up. But see here, this is the key value pair. On the left, we have the key, and on the right, we have a value. This is data that I have randomly chosen from an object, just to show you what JSON looks like. So this is JavaScript object notation. Now we're going to be reading from objects. So I'll show you how it looks in practice in just a little bit, but now we are working in JSON. Okay, so let's continue with the slide. Okay, and the way we get data from an API is through a fetch call. We have to fetch data from an API source. We have to use the fetch to receive from an API. Okay, fetch is a promise-based HTTP request API that is widely supported by modern browsers. It is used to make AJAX requests. We'll learn about a little bit of what this is. This is not fundamental to this lecture. Okay, so it requests in JavaScript, and it is a simpler and cleaner replacement for a different type of requests. Fetch is an asynchronous, so we'll learn about what asynchronous means. Is an asynchronous, so other functions will cite, and the site will continue to run even when API call has not been resolved. So what that means is, let's say a website has an API call. It's going to, let's say the website that we had built, the Dojo weather one, the practice assignment. Let's say we actually built it to get actual weather, and we're taking weather data from an API. And when we launch our site, it's live. People are visiting our site. When they load the page, and the page is loaded, but the data is still not completely there yet, that is an example of an asynchronous call. So do you guys remember the band NSYNC? Remember from the 90s? What does NSYNC mean? They are together in sync. So what does async mean? Async means it's not together in sync. It's not at the same time. So when you get the data to load your page, it may not load the data from the other API in time, and that's by design. So that's so that your web page doesn't, the loading speed doesn't depend on getting everything done at once. It's not depending on the API data call. Maybe it's a big call of data. Maybe the internet is slow for some reason. Well, it's not going to make everything hold up for just that particular function to fetch data. So that's why it's called asynchronous. Okay, we'll explain that a little bit more. All right, when a response is sent back from the API, the asynchronous tasks resume. So as soon as it gets that data, for example, the weather data that we're calling in our imaginary website, then it would just resume, and that part of the data will fill in, and the page will continue to function. Okay, to use fetch, you call the global fetch function to pass an URL and send a request to. The fetch function returns a promise that resolves with a response object. Okay, so when we use fetch, we're going to get in response an object. That's the JSON object, the JavaScript object. To extract the JSON body content from the response object, you can use the JSON method. which returns a second promise that resolves with the results of the parsing response body text as JSON. So that data that we receive, we are then going to convert it to JavaScript object notation. That way we can read through it as an object, and that's how we'll access the data. Okay, so here are some keywords that we're going to go over: async and await, and how they relate to a fetch call. So it should still all be very abstract. I know we haven't seen any code example. We're just talking about APIs, how to access them. Now we're accessing them through something called a fetch call that's asynchronous. That means this type of function is not going to hold up the line of the JavaScript code running. It's not going to stop everything just for that function to run. It's going to do it in its own time. And in order to make this function, this fetch call run, we need to use these keywords, async and await. So let's go over what those words are. Async and await. What do? They go together with fetch. So let's go over a quick explanation. In JavaScript, async and await are used to simplify working with asynchronous operations. That's a fetch call, right? Async would be a fetch call, such as fetching data from an API. The async keyword is added before a function to make it an asynchronous function. And the await keyword is used inside the async function before the call to a function that returns a promise. Okay, we'll go over what a promise means. A promise is something like when you, let's say you're getting you're buying some food. You're buying some food at your local burger joint. All right, and you make your order and they give you a number in return. They say, here's your order number. That's something like a promise. Okay, when you make a call and they say, okay, we're going to get you the data, but here's just a ticket, something that's as a promise that will show you that we'll get that order to you. Okay, the await keyword, the await keyword makes the code wait until the promise is settled. So the promise has to be fulfilled. That's when the function has finished, and the await makes it so that that promise doesn't hold up the line, like I said. And then either returns the fulfilled values or throws the rejected value. So let's say you're a customer at that burger joint. All right, you go there to get a burger and you stand in line. You stand in line and you realize that the line is long and it hardly moves. It's slow. And that's because the restaurant has decided that each person that orders, they're going to wait right there until they get their order, right? That would be an example of poor management. A better system would be to say, every customer that comes, they make their order, we give them a ticket, they wait, and the cooks continue to cook the food, and we take the next order. We stack orders and we give them these tickets as promises that they'll get their order. So that's the system that we're getting here. So functions, they have to run, but to keep a function from holding the line, we're going to make it an asynchronous function. So it's not going to get everything that it wants and hold everything up at the time that it wants. It's going to wait out of time until it gets that promise resolved. So the other functions can run just fine. Okay, so let's exit this slide. Let's look at our platform a little bit to get a picture of what we were talking about. Okay, so this is an object like we've discussed. Any data that you see in curly brackets with the colons here separating the key and value pair on the left and right, and commas, that's how you know an object is an object. If you see these key value pairs within a curly bracket here. Okay, so we're going to look at a function. This is an example of an API. Well, this is an example of a function that's meant to fetch data. It's a function meant to fetch data. We know that because it's asynchronous, and we see the keyword fetch right here. So let's expand this a little bit. Okay. We see the keyword fetch that is going to go to this website and grab the data that we're asking. Let's go here just to see what this data looks like. Okay, I'm going to this website. Let's go here. If I go here, there's this information. This is the API. Okay, I can change the view of it a little bit so it's more visible. All right, here's my object. I'm grabbing this data. I didn't create this from my app, so I would be borrowing this. And how I would access this data from my app is by creating a function, a fetch function, an async function, and we name it. And the first thing we see here is a variable called response. So this variable is supposed to hold the response of our fetch call. Okay, so our fetch call is an action, and before our fetch call, we see the word await. So this is going to make this function await the data from this fetch call. So the function will wait for this fetch call to finish, but since it's asynchronous, it's not going to hold up the line. And once we receive that data in this response, we're going to turn that data into JavaScript object notation. So the way we convert that information, convert that data, is by creating another variable. We're going to call that coder data. And we are also going to make this an await function. So we're going to wait till this is finished as well, which is the conversion. We're going to say response, which is the variable that contains that fetch call, the initial one. We're going to convert it to an object, JavaScript object notation. And that way, when we log this data, we can see this. We can see this data. So I'm going to take this here. And, well, actually, I want to show you guys something better. I'm going to show you guys a better API fetch call. I'll show you what I mean. Instead of taking from this API call and console logging the data, I'm going to show you guys an app that's built using an API. I'm going to show you the source, and I'm going to show you some fetch calls to that API. Okay, so let's look at the API itself. Let's look at the app. You guys remember your Pokemon shapes? So this is a game where I'm taking everything here is built with HTML and CSS. The information about Pokemon, though, I'm borrowing it from an API call. Okay, this is all information from an API. So I didn't have to create long lists of information about different Pokemons that exist in Pokemon universe. I just took it from a database, and I can take it from a database and create a game like this. So when you click the button, you have to guess who the Pokemon is. I don't know which ones these are because I don't know the ones past 151. So I'm going to just change that number. This is like my show to watch coming out of school in 3rd, 4th grade. Okay, so which one is this one? Can anyone guess?
Nidoran or something like that.
Yeah. Actually, did I do that right? It's not showing me the options. There we are. Okay. Which one is this one?
Wigglytuff.
Yeah.
Wow, you guys are scholars. What's another one? What's this one?
Piglet.
Oh, it's
Oh,
incorrect.
Pidgey.
We said Diglett.
Piglet. I thought someone said piglet. I tried to click Pidgey. What's this one?
Paris.
Paris.
Paras.
Aras.
Looks exotic.
Let's get
Okay.
the Gengar going.
Yeah, well, we're not. Well, the point of this lecture is not to play this game and guess all the Pokemon. But we know here that I built this using an API. I definitely don't. Oh, I do know this one.
Far-fetched, yeah, I was gonna say.
This one's cool. All right, so we are going to show how I got this data, where I got it from, and how I could build an app like this. Okay, so this is the place. This is the source. PokeAPI.co. I'm going to change the zoom so I can read it. All right, so here's where you can grab that Pokemon API information. And it gives an example. So it says here, if you want to use a fetch call, for example, to Ditto, this is what that response for Ditto would look like. You would get all the abilities, you get its ID number, you get its name, you get its height, different information regarding this specific Pokemon. Okay, so there's more information here. We'd have to read the documentation to fully understand how this API works. And most of the time, you have to read the documentation for any API to learn a little bit about how it works and how you can use it. Okay, I learned about how to make the correct API calls by going to this section here. This section here provides me with the information I need that I can call to make a single API call. So let's see what that looks like. I'm going to comment out the app, the game that you were seeing, and I'm going to reduce it to just a single API call. This is a function like we saw in Marissa's, for example, and we're going to make that call for Ditto. Okay, so let's see what this takes us to, where this is where we're getting our data from. Okay, it doesn't want to take me there. I have to copy it manually. All right. So copy and paste it here. So this is what I'm getting right now. This is what I expect to receive, all this information. And I'm going to go ahead and change the view. By the way, this extension name is called JSON View, JSONVUE for Chrome, if you want to see JSON objects a little bit clearer. Okay, so this is the information I'm calling from Ditto. All right, and here is my function call. I said async. That means it's going to do the fetch call, but it's not going to get stuck on that. It's not going to hold up the rest of the function calls that would follow after it just because it's still fetching the data. So it's going to do it in the background, run it in the background. That's why it's called async. And that's why we use those keywords await. Okay, await means it's going to wait for that fetch call to finish before the function finishes. All right, async just means it's not going to hold up the line. Let's get a poll running to give me some feedback. How well do we understand what a asynchronous function is and how to use fetch and await? Just those keywords, async, await, and fetch. How they're used in this function. The rest of it should be familiar. These are variables, these are functions. The only thing we're changing now is that we're grabbing data through a fetch call, and we're making the function wait for that fetch call. asynchronously. Then when we get that information, we convert it to JSON. So we say PokeData equals await res for result, res.json. So convert it to JSON, then let's console log it. Okay, once we console log it, we'll be able to see in our terminal. So that's what we are going to take a look at.
Do you use all those keywords together all the time? Or is it like, would you use async at one point and not use await, or use await without async, or use JSON without async and await? Is there, or
Typically,
they always
this
work together?
yeah, it typically looks like this. You'll see them
Okay.
working together just like
Okay.
that. Yeah, so this could be a call to someone else's, this is like someone else's database, right? Maybe an API call in the future will look like a call to your own database. It may look like this as well. Okay, but that we'll leave for feature stacks. Right now, we're just pulling the data and presenting it on our website. We're pulling it from pokeapi.co. and we're converting it to JSON. So let's take a look. This is our site for now. I removed the functionality, but the view is still there. If I check the console, there is that Poke data that I just consoled there. So let's open this up. Here's the JSON object, and here's the same data that we saw here. Now we just converted it to our own JSON object and then said console log that. So this is what we're seeing here. And we can open up these arrows to see what's stored inside. This is the JSON information that I had just received. Okay, let's take another poll. How well do we understand that this is a fetch call and this is the information in an object notation here in the console from my API call? Yes, Ben, the Chrome extension is yes. JSON view. Again, you have to practice with this in order to get some familiarity. So if you're seeing this for the first time, I can understand the, like, whoa, the awe of it. So, okay. Anything else we want to know? The rest of this, we're not going to take time to understand how this app is built. That's going to take maybe an hour or two because it's pretty in-depth. Here's the whole app. We can take a look at it together, but it's built off of API calls. So for example, if we break it down, we have different variables representing different features of the game. For example, the answer, what the correct answer is for the right Pokemon. And we're using the document query selector to access different parts of the HTML here. So this document query selector is grabbing different IDs. And here's our async function. It's going to fetch 151 Pokemon right here. This is the API call. So this is within the fetch. Then we convert it to JSON. All right, we take that res, we convert it to JSON, and then put it into this variable. These here are just grabbing the inner HTML of something in the HTML here. Then here is a function call for PokeData.results. So this is the PokeData, this is the object PokeData that we're getting the results. We're accessing the results of this object. And then we return it. When we return it, we can use that data from this function call, get Pokemon data, in the rest of the app. Okay, the app gets a little bit more complicated. You're going to have to note a lot more variables, and in order to get familiar with the new app, when it's just dropped on your lap, it takes some time to get familiar with the geography of the code. So that is like reading it, understanding what different variables are, how they connect with each other. So I wouldn't expect you guys to just read this for the first time and understand how it works, the inner workings. But we can read it now, and we can actually figure it out if we did take the time, because we can now understand what an async function is, how it fetches data, and how we can use that data and manipulate it to make some questions. When we can use math, we can loop through a call of 1 through 5 of the 151 Pokemon, and then we can use math.ceal with math.random to give an option of different Pokemon to select from to try and guess the name of the Pokemon that we are trying to guess from. And so what you guys can do is, in your own time, I'll push this code. You guys can try to understand it if that's what you'd like to do. Okay, that I will just leave that option there. But I wanted to show you guys that this app works using an API call. And so we have a few keywords: async and await, and fetch. Fetch call, that's where the information goes that you're fetching. And we convert that to a object so that we can read and parse through that object as we would through any JavaScript object, right? So here's an object. If we wanted to access abilities, we'd have to get the key abilities to access this array of information. Okay, does anyone have any questions about APIs?
I did have a general question. With APIs, are most of them just like public access, like information, or is there some that you would have to pay for, or is it like a strict market? Or
all
okay.
of the above. Some of them are free. This Pokemon one was free. There's a Harry Potter one that's free. There's weather ones that are free. So you can Google search different APIs, and there's APIs for lots of things out there. There's also private APIs that companies have built for themselves. So let's do a Google search. Top 10 free APIs. Wait, I clicked the sponsored link. That's never good. Yeah, I did this. I searched this before. Marketing APIs, website APIs, email and messaging APIs, map APIs. You can incorporate a map into your website to show where your location of your business is using a map API. You can use news APIs to present news articles on your website. You can use image and video APIs to show, changing of different images, or just borrowing image instead of having to have an image or video sourced on your own machine. Social media API. So some of them are free, some of them you do have to pay, some of them have both. Like they have a free version and then they have a paid version that you can use. But some of them are private, like company APIs. They don't want access to. So there's different levels. APIs are totally different levels. Yeah. Okay, so that is our introduction to APIs, everyone. You'll be taking advantage of them, using them more often. I've had, in my experience, like a screening question. Someone just asked, if they're trying to figure out if I'm an experienced developer, they'll just throw a question. Do you know what an API is? And then you can go on a long description, and then they probably don't know the answer. But as long as you're confident answering, they're feel more confident giving you the job. So, but now you actually know what an API is and how it works. And you can take the code, tinker with it, build your own API. So next week, we're going to have projects. Maybe you can start thinking about what kind of a personal project you want to build for yourself. If you may want to use an API, if you don't, we'll talk more about that later on, but you can just start searching different APIs and seeing how they work and playing with them to get familiar with them. Okay, so about the material that we're going to cover today. So we no longer have core assignments. If you pass the test that you need to continue, all of these assignments now are optional. We do have some lecture times that we're going to cover a lot of new material, but for these couple days, Thursday and Friday, there's nothing that's going to be due by a certain date. So we'll let you know that after the test, the stress level is going to go down because we're going to project week, right? So we're going down, and it's going to simmer down until you start Python in a week and a half from now, about a week and a half from now. Then things are going to get hard. So enjoy just learning while there's not so much pressure until it starts up again. And if you need some stuff to work on, let's go back to where I was previously.
Will we get new or additional information on what project week will entail so that maybe we can start early for stuff like that or look
Yes,
into?
so on this advanced topic section here, you can look at portfolios. Portfolios, what we'd recommend that you would build on your own project week. You can group up with someone else in your cohort and make your own project that you can think of yourself if you don't want to make a portfolio. But we recommend making a portfolio where you can host other upcoming future projects, and it's an additional presentation to your resume, to your LinkedIn, GitHub, so you can have a portfolio as well. Here's some examples that you can look at, get inspired by. You also have these different practice assignments. You can add some of these if you build them to your website portfolio that you may make next week. So you have these calculator, you can make a calculator and push that on GitHub, and then also link it to your portfolio. You can make a calculator using JavaScript. You can use a clock, a ticking clock. You can also build the Pac-Man game. And this 1942 app. So this is an interesting couple of days that you guys have where you can maximize on what you want to learn for yourself, pick your own practice and optional assignments, and focus on what you'd like to learn. The topics for tomorrow are going to be Bootstrap, and Narciso's volunteered to do that demo, so it'll be fun to get a lesson from Narciso there. We can figure out how Bootstrap works and how we can use it. Highly recommend Bootstrap. And then in the afternoon, you have a lecture about media queries. That is checking the view of your browser, depending the height and width of it, depending on your mobile, your device, whether it's mobile or a desktop monitor or an iPad view. So we're going to learn how to check different media view heights and adjust our website in order to do that. Okay, we're going to figure out how to do that tomorrow afternoon. Okay, so you guys can pick your own course for the next couple days, and then next week we're going to be in sync doing the project that you would have chosen to do as well. Okay, so we'll get into that next Monday. I don't want to give off too much information about that, but you guys can start to choose your own path a little bit more. And this afternoon, terminal is going to be the topic of lecture. So that is this thing, the place where you can enter in command lines and view your folder file structure from here, instead of just looking at your desktop and clicking folders and creating files from icons. You can also access through the terminal, and you have to use this for some key parts of coding. So we'll break down what this is and how we can use this later. Okay, any questions? Okay, all right, so then I'll stop sharing, I'll stop the recording.